Hello everyone. So today I would like to introduce some knowledge about GPS before you study laser scanner. This is all knowledge you have to study. So first, you need to understand latitudes and longitudes. Okay. So what is this? If you look at our Earth, you see from this equator they divide up to be this degree, north and the south, the same, right? Let's say in this example, Canada, you see, they said the degree latitudes at north is mean above the equator, and longitudes west, you see, here, and it's called based on your degree. You see 0, 30, 60, right? Okay, you see the minute. Second, you have to understand what is UTM. This is the 2D coordinate system to give location on the surface of the Earth. So let's say the map. We have the map for UTM. You see, this is the map for UTM. So how can we understand this map? Let's show some example. So example, we look at is our country, Vietnam. So this square, right? From the map, you see. So how can we understand? Let's see. This is UTM, Ho Chi Minh City, located in 40S and P. You see here, right? In zone 40S and P. So another example is, let's say this mountain in Canada. So where is this? Here. So how can we interpret this? 11U, right? Because it's located here, exactly on the map. 11 and U. Okay. Next, you have to understand easting and northing. Normally, they will write the coordinate of one location in this term. First zone, easting and northing. Easting refer to S coordinates and northing refer to Y coordinates. And this is we need to have a zone, because I will explain for you later. Maybe the one location between two different countries have the same easting and northing, but they are located in different zone. Okay, and this is UTM coordinates. Based on UTM map, they separate to be coordinates up and to right hand side. Okay, let's see example. Let's say in this point in Canada, in this square, right? For each square, we start from this coordinates up to this coordinates. It's the same for all square. All square from left to right, it start from this value to this value coordinates. So let's say this point of this location in this square, so easting and northing, you can see it, the value of easting E between this value to this value. The value of N is from equator. This means the distance from equator here. This distance from equator to this point, and it starts from 0 to 9,300,000. Right? But if some location below the equator, maybe you have to change, not maybe starts the distance from here up to here, right? So let's see another example: Bangkok in Thailand and Ho Chi Minh City in Vietnam. Let's say this pen for Bangkok, right? And this is for Ho Chi Minh, right? You see? You can see from here, and finally we have the data. That's why you see they are different zone, but maybe some point that we have the same easting and northing, right? Because this condition, you can see, right? That's as I told you, all the corners of each square start from 167,000 up to 133,000. Okay, I hope you understand. This thing, let's say in Bangkok, this point, this location, right? This means the distance from here up to here, and then you have to plus this value. Okay. Similarly, is the nothing is mean the distance from here up to here. Okay. So that's it's possible, right? Some location is might be possible, but just different zone between two country. Let's say that on the location on the horizontal line, right? So it might be possible. So how can you check easting and northing of some location? You can go to this website and then you can see something like that. And when you move your mouse cursor here, they will show the value of easting and northing, and they also show the UTM zone. Let's say you move your mouse here, you see this means now this location have this coordinates. Similarly for Ho Chi Minh City, you see this value easting and northing. Easting have 6 number, northing have 7 number, right? And the next, how to convert from easting, northing to latitude, longitude. So you follow step by step. For example, you have this location, you just go to this website, you input the data, and then you click convert, and then it will show you latitudes, longitudes, right? So you also can recheck by using Google Map. You enter, maybe you try to find the name, then you see latitude and longitudes similar to the result you just obtained above. And how to find this dimension 2 point UTM Grid when it's still nothing knows. You follow step by step. First, you go to this website, you convert to latitude and longitudes. Let's say in this example, I show in Thailand zone. So then you go to this website, they will compute the distance. In this case, let's say the dimension 21.7. How can we recheck it? You can click here, they will plot here. Okay, this is I call general methods to find the distance between 2 points. We did not consider it's in the same zone or not, right? Because in the step 1 you have to put the zone. So specific example, if 2 points in the same zone, you can quickly compute the distance by using this formula. You see, I repeat the previous example and I get the same result between 2 points. And next I would like to introduce to you RTK, real-time kinematics methods. And normally here I focus on accuracy is up to centimeter. Here I show you the application of RTK. In this case, we use RTK to measure the pitch profile like this figure, right? And we measure along the pitch like this. We have rover, and this will show you the result. Okay, and the last elevation, how to understand the elevation, this is GPS and MLS. It means sea level. So, and you look at this figure, you can imagine for mean sea level, this is the blue line. But for GPS based on the World Geodetic System WGS84, we assume this is real global. This is theoretical sea level. Okay, and this is the meaning. This depends on the location of the object, and n is equal to GPS. This means the orange line subject, the blue line. Okay, how to find the elevation n? Let's say you have this location, right? On this place, you first search on Google Map, then what? You have to input the data here. You have to find the latitudes and longitudes you go to this website, okay, then you click submit, then they will show you the result. In this case, this point is 31.5 above the sea level. Okay, thank you. Bye bye.